Hello everyone. Today we'd like to discuss the different options you have available for getting communication working with Victron systems using different devices such as the Cerbo GX, Cerbo-S GX, or if you're using your Raspberry Pi with the Venus OS, what you need to do in order to get communication to work. So we'd like to go over our basic system first to give you an idea what we have set up. We have two SFK 300 HP batteries with the data ports and the SFK data cables. These cables are RS485 to USB, and you can see here, we have them just sitting here. We have a Victron Multiplus II. This is a 12 volt, 3000 volt amp, approximately 2800 watts. And for the first setup, we're going to be using a standard Cerbo GX, just showing you the process to do it. If you want a more in-depth detailed video on how this is done, you can certainly watch our first video where we show you how to connect multiple batteries. In this case, we'll be just using two batteries, so we'll be using two of the data ports on the Cerbo GX's USB side. The way we have it wired, our inverter wired up, we have 4 equal length cables. Our red and black are 2-gauge cables, and they're the exact same length. One of the advantages that we have with the Victron Multiplus II is that there are dual ports for red and black, so each battery can connect to the inverter independently. We are using, for this test, we are using a modified sort of extension cable. This is 12 gauge, and that with a 3-head. It's not permanently mounted. This is just for a demo. Normally you would have it mounted with a little bit of slack and then secure it down with the cable hold down, but for this test we just kept it simple. And finally, for our data communications, we have a standard Ethernet Cat5 patch cable, about 5 feet. So that's a little bit about how our setup is, and we are also have our Cerbo GX set up. It is set up so that we can see the information on it, and see here, and we're currently connected to it on our device on with IP address ending in 0.57. So with that being said, we'll first set up the Cerbo GX. What you'll need to do is download the driver from our website and put it on a small USB drive. It just needs to be something like a 1 or 2 gigabyte. Doesn't need to be big, but in this case it's a 32 gigabyte, and this works fine. We have instructions on how to do it, but essentially you will download the driver, insert it into one of the 2 USB ports on the Cerbo, go to the menu of the Cerbo, perform a reboot. Once the device is rebooted, it will read the driver off the drive, wait about 4 or 5 minutes, then proceed to do another reboot. After the reboot, unplug the drive. Once the drive is unplugged, the SFK drivers are installed. Okay, and that process is explained in our first video, so go back and go ahead and look at that, and we'll discuss that. Okay, so let's see what we need to do to connect it to the Cerbo GX standard. Okay, and we'll proceed with that shortly. So we've connected the inverter to the VE CAN bus with also the terminal disconnect, and also we've connected the 2 SFK batteries to the 2 data USB ports. Now that that's connected, let's actually see what we see on our device. We see it reads the Multiplus II, and it reads SFK BAT1 and SFK BAT2. So both batteries are connected. You can rename these batteries by going to the menu options. If you want to rename them, you can rename them. As far as what it determines, the 1 or 2, it depends on the port. The battery connected to USB port 1 will be called SFK BAT1. Battery connected to port 2 will be called SFK BAT2. In a future update for the driver, we will actually be basing the IDs on the barcode or serial of the battery, but for this version of the driver, it is based on which port they're connected to. But as you can see, using the standard Cerbo GX with the VE CAN and the 2 USBs allows you full communication with the batteries and the inverter, and you can also set up stuff such as limiting the current, deciding the minimum state of charge. This will also tell you how many amps are coming out and going in of each battery, As you can see, SFK bat 1 is 54% and SFK bat 2 is 51%. Slight voltage differential. So that will sort of help you determining how it is. Now, we have a heater connected. So let's just turn it on to like 80 to trigger it. And once we do that, we will see that as we increase the load, we're now seeing the different amps coming from different batteries. For example, SFK bat 1 is drawing about 74, and SFK bat 2 is drawing about 57 amps. And that's because they're a slight different state of charge. But that is all something that you can now see. So this is superior to just a shunt because you can actually see the amps per battery instead of just over, how overall it is. So you can see which battery is drawing what. And all that is available for you to see. Okay? So let's go ahead and turn it off. And when we turn it off, we will see our amps drop. And as you can see, they have sort of dropped a little bit. Okay? So that is the standard Cerbo GX. And the reason, if you want the maximum capabilities, you go with the Cerbo GX because it has pretty much all the ports that Victron offers, including the VE Direct ports and HDMI, both BMS CAN, VE CAN, and the VE Bus ports. So maximum number of ports available, and this will run you somewhere around the 300 mark. Okay, now with that out the way, we will shift our focus to the Cerbo-S, which is basically identical to the Cerbo GX. However, these two ports are blocked, so it does not have the BMS CAN ports, but it still has the VE Bus and VE CAN ports. Some other features that this does not have, it doesn't have some features such as some of the tank monitoring, so those are a few things that are not available on this. But let's see what we need to do in order to get our batteries to communicate with this. So we'll disconnect our cable from here, plug it into here, and then transfer our batteries and plug them here, and we'll see how that works. Alright, so we'll do that next. Alright, so we have now connected to the Cerbo-S GX. And just like the standard Cerbo GX, in the Cerbo-S GX, we've connected our two batteries to the first two USB ports. Make sure you understand, the USBs that you can't connect to have this icon of the USB. This is power only, so if you connect your battery to here, it doesn't work. If you have other items connected to your USB ports, all you need to do is purchase a small USB hub. You can connect that to there and then connect your batteries to that. Watch our first video how we show you how we've connected 4 batteries to a single port. Our driver supports up to 8, so you can have 2 USB hubs on 2 ports and up to 8 batteries connected. But once again, just like the Cerbo GX, on the Cerbo-S, we've connected the 2 USB and we've connected the inverter to the VE bus. So let's see what we see. So in here, we see the same thing. We see Multiplus II is here, and this is running on the 0.96 IP. So we have this information here, and again, we can sort of see the same thing. If we are to turn on our heater again, and we'll set it to 80 degrees to get it to kick on, maybe 90, we will once again see the amps being drawn from the battery. And that shows us the amps being drawn from each battery. So we're able to view individual amp draw, and that is superior to just a shunt because now you can see how each battery is working. And of course, the one that's slightly higher charge is going to supply a slightly higher amount of current. The one that's a slightly lower state of charge will supply slightly less. Okay, but there you go. Cerbo-S GX works just fine. If you're only looking to install basic stuff, you might want to get this. This one will run you slightly over $200. The market price on these is about $215 to $217. Okay, so we'll go ahead and turn off our heater. Alright, now that we've done the Cerbo GX and we've done the Cerbo-S GX, let's talk about a DIY device such as this. Now this is a Raspberry Pi device. It's a Raspberry 4B, and it is enclosed inside of a mini case that also has an LCD screen. So we'll talk about what you need to do in order to do this. This is probably going to be your cheapest options. Just be aware, you will need to buy some additional cables for this to work. So It by default, just the case will run you about $100 with the Raspberry Pi and the case with the LCD screen, but you'll need to buy some cables, and the cables can cost you a little bit. So we'll go over some of the cables before we start setting this up. So let's talk about the cables. The first cable you're going to use is this interface to MK3 USB, VE bus to USB. What this will basically do is it will take the red wire that's normally coming out of the inverter, this Ethernet wire, and you will plug it into here. And the reason you have to do this is the Raspberry Pi only has USB ports, so you'll need a way to convert the communications coming out of the Ethernet wire to USB. So that's the first thing that you'll need in order to get your inverter to talk to your Raspberry Pi. The second cable that you'll probably need is a VE direct to USB cable. If you're using solar charge controllers, which most people that are using Victron probably will be using their charge controllers, you will need a way to connect to the charge controller, which is going to be the VE direct port. And then again, since we're talking with the Raspberry, you'll need a way to connect to the Raspberry Pi, so you'll need a USB. So unlike the Cerbo GX S or Cerbo-S GX and Cerbo GX, the Cerbos already have a direct cable, so you can get the cheaper VE direct to VE direct cable. However, since the Raspberry Pi does not have any of these, we actually need to get a VE direct to USB cable. So these cables will add about the cost. Depending on where you can buy them, they can be as cheap as $30 to as high as $50, depending on where you buy. But it's probably a good idea to budget about $50, $60 in at least 2 cable adapters that you will need in order to get it to work. Okay? However, one thing that's good is that you do have a touchscreen, and you can save some money by getting a version without the touchscreen, but this thing does have a touchscreen, and you can use it to connect your things and do it. And it also has a, let's see here, it also has a web interface, so you get the advantage of both. You can view it on a tablet or your device, or you can view it directly on there. So just like the Cerbo and the other devices, we're going to connect our batteries to that and then connect the inverter through the adapter onto that as well and see how it appears with all of them connected. We'll do that next. Okay, so we've now connected our batteries to the Raspberry Pi running Venus OS and Raspberry Pi 4. So let's see how we've connected them. We've connected one to port 1, the inverter is connected to port 2, and the second battery is connected to port 3. So you can see the inverter is connected. The Ethernet cable coming off the inverter is going to this adapter. This adapter is then going to the Raspberry Pi. So it shows us all 3 of the devices. Now, you may be wondering, hey, what's going on here? I have BAT 1 and 3. What happened to 2? Again, based on the port that we're connected to, it's going to be named that way. But you can always custom name them. So if you click on BAT 3 and then go to Device, click on the name, click on it again. Sorry. You can then go in and rename it. So it is possible to rename them to say whatever you like. But for this demo, we're just going to keep it the way it is. Okay, but again, we see our batteries, they show up, we see the inverter, and we see that. So let's do the same test with the heater and see how it works. Turn the heater on again, set it to 80 degrees so that it kicks on. It'll detect it that it's not 80 degrees, and let's see what happens. Okay, and once again, we see we're having BAT 1 providing 75 amps and battery 2 is providing around 57 amps. Okay, so just like the Cerbo GX, Cerbo-S GX, and the Raspberry Pi running Venus OS, you can get all of your data appear on the system. So depending on which one you prefer, you can go. I do like the Venus OS as the flexibility because there are various enclosures available, and if you need a larger screen, for example, you prefer a 7-inch screen or a 12-inch screen, you can purchase those larger screens. But the Cerbo-S is also very good and doesn't require you to buy a lot of adapter cables. Depending on how many devices you have to connect to your Victron Venus OS Raspberry Pi unit, you may end up spending a lot of money on adapters. The Cerbos, on the other hand, have a lot of these ports built in. So like the VE Direct cable is considerably cheaper than the VE Direct to USB cable. But generally, if you only are using two devices, such as the inverter and solar charge controller, and need them to communicate, the Victron running Venus OS on the Raspberry Pi may be an attractive option for you. But all of them work, and all of them have their advantages. So decide on which one that you may want to do. However, our driver should work with all of these devices, and you should have no problem getting it running. And again, we support up to 8 batteries. So if you need to attach a small USB hub to there so you can attach more batteries, you can. But this should just work. Okay? Alright, so that's the video explaining how we attach different devices to the Multiplus II and the integration that you have available for the batteries. Again, these are 300 HP batteries, but it works the same whether it's a 275EX or if it's a 24 volt battery, or if it is a battery kit that you have decided to add a data port. You do need to purchase the data cables with the data port. Alright, well, if you have any other questions, feel free to reach out to us. We're more than happy to help. And once again, thank you for choosing Sun Fun Kits.